So we say, how do I find a minimum distance of y equal to 4 minus x squared, and find a point on the function that's closest to the point 0, 2. Okay, 0, 2. So let's graph this function first. And for me, I graph this function. What do you guys know about this function? What do you guys know about this function?
Opens downward.
What is it?
Opens downward.
Opens downward? What kind of equation is that?
Parabola.
Parabola open downward. Okay, what else?
Its maximum is going to be at like 4 because it's shifted up 4 units.
Shift up to 4 unit. You guys are genius. Okay, so the vertex is going to be right here, facing down. What else?
Has x-intercepts at -2 and 2.
Why is that?
So if you look at the graph, it's 4 minus x squared.
Mm-hmm.
So it's equal to 0 at those.
So yes, that'll be a graph. Now where's 0, 2? 0, 2 is right here. Now this is not exactly a symmetrical graph because I kept my hand shaking. But technically, where do you think the shortest distance occur? By looking at it. My ugliest graph. Where do you think that occur? At 0? Katie says no, not at 0.
Wouldn't it fairly close if you like your -1? I don't know if the graph is making it.
I'm pretty close at -1.
Or it also could be at like 1 as well.
It could be at 1 as well. Okay, well let's talk about it. What kind of formula I need to use here if I want to find out the shortest distance?
Distance?
Distance formula, good. So let's write down distance formula. Distance formula equal to x2 minus x1 squared plus y2 minus y1 squared. Now, the distance to which point? Obviously is to the 0, 2, right? So we're going to say x minus 0 squared plus y minus 2 squared. Does that make sense? Because that is the distance. Are we okay here? Now, can I replace that y? We obviously has a primary equation. The constraint is within you. You see the constraint. The constraint is the function. Does that make sense? And that's will be what the test question look like. And now, don't kill puppy. Don't distribute the square. Write it out. 2 minus x squared times 2 minus x squared. If you need to do it on the side, write it out. And I'll write it out. It's going to be 4 minus 4x squared plus x squared. So it's equal to x squared plus x to the 4th minus 4x squared plus 4. So that's equal to x to the 4th minus 3x squared plus 4. Yes, Dashan?
Wait, why is it x instead of y in the parentheses?
Which one?
Like y minus 2 squared, you put x squared?
Yeah, because this is y, right?
Yeah.
I replace this y with this.
Oh, okay.
So I'm going to write down replace. That way you can see what happened. So replace. because that's a constraint. The constraint is a function itself. So you use that constraint to reduce a variable from x and y to just only x. Does that make sense? Now the next part is actually, you can choose to chain rule into this, but for me, I won't even bother. For me, I'm gonna say d is equal to x to the fourth minus 3x squared plus 4. Now, you're gonna be like, whoa, what did he just do? He just do some like math, like wizardry that just get rid of square root sign because they feel like it. But thing is, it's not I feel like it. The reason is things I only interested in the inside material, whatever is the maximum inside the material. Because whatever inside the material, it doesn't matter if I square root or do not square root. Right? If your maximum material is 100, your square root is going to be 10. But if it's 36, square root is going to be 6. So 10 is still greater than 30. 10 is still greater than 6. Does that make sense? So it's relative. So it's going to square root anyway. So I might just just pay attention what's inside. I don't need to worry about the chain rule and chain rule and the things. Although you could get done with chain rule, just the one extra step. It's not a big deal. Then I'm going to take a derivative of this. That's equal to 4x cubed minus 6x. And I'm going to set it 0. And that's 2x squared minus 3. So 2x equal to 0, which is x equal to 0. 2x squared minus 3 equal to 0. X squared equal to 3 over 2. X equal to plus minus square root 3 over 2. Now we got 3 critical values. So which one's which? Which one's going to give me minimize? Well, is it 0? Possibly.
Do we plug them into like the original distance formula that we made before?
Yeah, you can, but that doesn't really ideal. What you can do is you can do the second derivative test because that's much more efficient. So I'm going to do second derivative is equal to 12x squared minus 6, right? I'm going to plug in a couple value to see. I'm going to plug in 0. If I plug in 0, I got negative 6. If it's a negative 6, is what?
Concave up.
Concave, not up,
Oh, down.
down. If down, then it's
A maximum.
a maximum. So this, at 0, is a relative max. But it's not minimized distance. It's maximum distance. It's a small relative max. Now let's do d double prime of square root 3 over 2. Now it doesn't matter if negative square root 3 over 2 or positive square root 3 over 2. They're always going to get the same thing in this case. So it'll be 12 times square root 3 over 2 here. And square is equal to minus 6, sorry. That's equal to 12 times 3 over 2. Minus 6, that's equal to 18 minus 6, that's equal to 12. If the 12 is concave up, right? Concave up means a minimum. So then if you plug in negative square root 3 over 2, it's also going to be the same thing. It's also 12, so it's concave up too. So it doesn't matter. So now, with that being said, you say, okay, well, great. We find all the information. Then we still have to find a coordinate. How do you find a coordinate? We know the x coordinate.
Plug it into the original function.
Plug in the original. So it'll be y equal to 4 minus square root 3 over 2 square. So it's equal to 4 minus 3 over 2. I think it's going to be 5 over 2. So therefore, the point is going to be square root 3 over 2, 5 over 2. And the negative square root 3 over 2, and 5/2.
Okay, so we're searching for the relative minimum, and so you just, are both of those our answers, or?
Not 0 though.
Okay, yeah.
0 is relative max because that's maximize. That's not minimize. You want to minimize. Here's a question for you to try it. The question is, the function's f of x equal to square root of x. It's going to be 4, 0. You guys can try this one.
Is the 4 and 0 your interval?
No, 4, 0 is a point.
Oh, like one is closest to that?
Yeah.
Oh, okay.
So you see that square root x graph is going to be something like this. So from this point to this point to this point. And see what's the 4, 0. But you had to prove calculus, using calculus.
Okay.
So this is for sure a question that I will test you on.
What would the answer to this one be?
I don't know. Did you do it?
I think I did it wrong.
Check with Kevin.
What'd you do?
No, no.
Kevin, why are you so slow?
I'm not awake yet today, being perfectly honest.
What'd you say?
I said I'm not awake yet today, being perfectly honest.
Yeah. I started with random search of 12 places. And also dogs. I'll tell you in a second in Sanka. 3-7, page 15. The answer is 7/2.
Well, what's the y value?
Huh?
What's the y value? Just like the
Square root
square
of 7/2.
Magic. Okay. What do you call
You got it right? Oh, congrats. 7/2, comma, square root of 7/2.
I think you plug it back in.
Oh, yeah, 7, 2,
So you reorganize this equation, so let's f of x. So f of x
Is that
equals
it?
y is x. So y
Oh,
equals
so
the
you
square
just
root.
use
No, 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 no. So y equals the square root, right? If we square both sides.
and then for the other y,
It means
you
that y
use the whole
squared
equation.
equals.
Yeah,
That's
yeah.
what your value
I just wasn't sure like where
So
you
that
guys
means
pulled
that
it, because
technically.
for the first one, I didn't know where you got the 0 and 2 from, but it was because it was on the y-axis, right?
Did you really do that?
Right for the first one, where you get like the points that you plug into the distance formula.
Don't kill puppy.
Yeah, that's what I'm seeing now. I didn't see that, so I didn't know that you were supposed to use. Okay, that makes sense.
Do you not know how to get some of it?
Okay, so you get to the number two, exact, and then just plug in the tens.
Yeah.
This one was
Do you
like
understand what
way
it is?
less work
Yeah,
though
okay,
than
got it.
the
Oh,
way
okay.
it's done on last
Yeah, I
year.
just put it back in.
Square root of.
This problem was strange. I
And,
think I saw it the wrong way technically. I would have read it with the legs off. You got it.
so we should use it here. So what he did with the first one, he did the same process.
So this answer will be 7/2
He found that there's two of them.
and the square root of 7/2.
Yeah, then
You're right, you're right.
And then he found that this was the closer one.
yeah.
And this, there's only one x, so there's no.
That makes it a lot easier.
This makes no sense. A rectangle is balanced by x something. Oh, x. What you can do is show the rectangle how.
So a rectangle is bounded by x-axis. X-axis. So I'm gonna draw out the x-axis right here. I'm gonna put in red. And then this is x-axis because that's the boundary. So I'm gonna readdress that again. So that's the red part. Okay. Now, do you know what the square root 25 minus x squared shape is? You have to know this.
This would be what, 5 minus x?
No, he just killed puppy again. Jesus. What is the equation of 25 minus x squared? Do you guys know what shape is this?
Yeah, it's an upside down fraction.
Almost.
Well, like up 25.
No.
No? Well, I know, that's, I was saying without the square root. I have no idea what to do with the square root.
You have to know this shape. This is a very common shape. Look at here. Y equal to 25 minus x squared. Can I square both sides? Does that remind you what kind of shape?
Was it a circle?
It's a circle, yes, with radius of 5. But except this one's a positive, so it's a semicircle on the top. So that is going to be a semicircle like this. This is very ugly. Okay, I'll finish making video on this one on fourth period. But watch this video, you're gonna have a